Advent of Code 2024, Day 22, Monkey Market. This is OXDF, and I'm coming to you from not my normal setup, so I apologize, no video today, and sorry, probably poor audio quality, but we're doing the best I can here. Let's take a look at the challenge. So there's a lot of story here, but the main point of this challenge is going to be taking some, I've got each line in my input is going to be a seed value, and I can then use that seed value with some modifications to get a random number or a pseudo-random number, and then run the modifications again, get the next pseudo-random number, use that as input to the next one, et cetera, and keep generating a stream of random pseudo-random numbers. And so the process they give us is to take one thing, a seed, and generate the next random number, is multiply by 64, then mix the secret number with that result, then prune the secret number, then divide that new secret number by 32, rounded down to the nearest integer, mix that back into the thing the secret number, and then prune, and then multiply by 2048, mix that into the secret number, and then prune. And mixing and pruning is actually really simple. Mixing, it just means doing bitwise XOR, and pruning means taking the number modulo 16777,216, which happens to be 2 to the 24th. So they give us some examples. So if we start with 1, 2, 3, here's this, that it goes through that process and generates 15887,950. Then you can take 15887,950 and put that in and get 16495,136, et cetera, through this whole list. They are going to give us an example input of 110, 100, 2024. And if I do that 2,000 times to each of those, I will get the following numbers that are given here, and then I can sum those up and get 37327623, and that is the example solution. So they say, do that for mine and get my thing. Now I've already solved this. I'm not in a position where I was able to solve this earlier today, but I couldn't record at the time. So, but we're going to start from scratch and just run through it because this is a pretty straightforward challenge, I thought. All right. On this computer, I don't have access to the Genday script, so I've kind of pre-composed that for you, so you don't have to watch me copy and paste and generate subs. But I've got the input here. The input is long. It's 1,557 numbers. So we will have to make sure we go at some speed. I've got an example here of 1, 2, 3 because I want to be able to see that stream when I'm generating it and make sure I'm getting the right things there. And then I've got the actual example for 1 of 110, 100, 224. I've got another example here because I hate when they do this, but the example for part 2 is different. Why 110, 100 wouldn't work and 1, 2, 3 does, I don't know. But so I've got that there. We've got our stub. So let's go check out what can we do. We want to create a function that will do the mixing and just the generation that they describe. So next num takes an x, which is an int, and it returns an int. And what are we going to do? We're going to say x XOR equals, and we're going to say the first one was x times 64, and then modulo, which is that, and then I'm going to need that number. So where is it? Right there. Boom. And then we're going to do the same thing, x XOR equals x divided by 32, modulo, same paste, and then I'm going to do the same thing, x XOR equals, and so when I do XOR equals, that's the same as doing equals x XOR, that's the same as doing this, x like that. I don't know, just saves a few characters, I guess. Same as like doing plus equals adds, well, XOR equals just does XOR, there. All right, and we are going to do this, x times, I think it was 2048. These are all powers of 2, modulo, and paste. And we are going to return x. I think it's that simple. So what we're going to do is we're going to, let's come down here and we'll do for blank in range 10, print next num. Oh, actually, sorry. We'll say print num equals, let's see where we come up here. Actually, let's change our input here. We'll do it. So instead of list mapping string strip here, we're going to map int, and that'll just give us a list of integers. And now we can say num equals numbers, and we'll come here and do numbers sub 0, just because we're just going to get the first one, which only is one in this input we're going to use, but that's fine. We'll say num equals next num of num print num. And we're going to run this, and we'll do Python day, we're not in the folder, cd day 22, cd day 22, Python day 22, example.txt, and we're going to get a handful of outputs, and hopefully these are going to line up nicely with this right here. So 1588, 1649, 527, 15. Yeah, so we are generating numbers the correct way. That's really all I wanted that first one for. The next one we're going to do is we're going to say, okay, so we'll get rid of this. We're going to say for num in numbers. I guess I could have done that last time when there's only one. Now, what are we going to do? We need to get the next, we want to run it 2,000 times. So we'll say for in for underscore, an underscore, we just use underscore to represent a variable we don't need. We have to have something there. So now we have that, and we're going to say, we just need to say that we definitely don't want to print here, but we want to store the result in part one. So we're going to say part one equals 0. And then after we do that loop, we'll say part one plus equals num. And we'll get rid of this, and we'll save. And we're going to run on example 1.txt now, and we get 373,27623, which is the result here. So we can now take this and run this on our input, and it hangs for a second, but not too bad. 1, 2, 3, 3, 4. 1, 2, 3, 3, 4, 7, 1, 5, 4, 9. Yeah, so we got it. We got that right. Part 2. So part 2 is a little more complicated. Each buyer, for each initial seed, I can run the numbers through. And along the way, the output is actually not going to be the resulting. So like my 1, 2, 3 example, right? I need to kind of keep track of the price, and the price is just the last digit. So 3, 0, 6, etc. generates these things. And I actually need to look for not the prices, but the change in prices. And I need to look for 4 changes of prices in a row. The fingerprint of a price will be the 4 changes leading up to it. So for example, if I wanted to target this 6 down here in for 1, 2, 6, 8, 3, 1, 5, 6, the fingerprint for it would be -1, -1, 0, 2. And I need to figure out what fingerprint I can give such that I will maximize the price for each. So when the fingerprint is hit, the buyer stops, and I get the price, so in this case 6, right? So I need to figure out how to maximize that across all my inputs. And so let's see, did I describe everything I need to describe here? So for these 4, I want to see like, okay, what single fingerprint can I give all 4 that'll give me the most? And so they give me an example here of like, if I give the fingerprint -2, 1, -2, 3, I get 7 for 1, I get 7 for 2. I never hit that fingerprint in the third one, and then I get 9 for 2024, and that happens to be the highest, 7, so 23. So what's the most I can get? So this gets a little bit more complicated, but it's not too bad, honestly. Okay, the first thing we're going to do is we're going to go through, and instead of here where we're doing the underscore, we are going to need to capture the, I'm going to call it outputs. So we'll say outputs is equal to, and this is going to be next num of num for, I guess we don't need, we can still underscore here for this, in range 2000. So that'll be all the output. Now for part 1, I want to capture that number. So I can say num walrus operator equals, and then I don't actually, so what that's going to do is it's going to set this value num equal to the result here, and then it's going to keep going. So that now when I get out of here, let's see, we can get rid of you. In theory, right now, I still solve part 1 just the same. We should check that. It took a second, but yep, still solve part 1. So, but now I also have this outputs thing. Now I don't actually want outputs to be the full numbers. I want the price, and the price is going to be this whole thing mod 10. So now outputs is going to be the last digits of those numbers, but I'm still storing num, the full number. So again, we can make sure that input still works fine, and it does. So now we've got this list of outputs. So but I actually want to get the list of the price differences. So I'm going to say diffs is equal to, and to get the diffs, I just need to get successive things. So I can say y minus x for x comma y in outputs. Zip outputs, comma, outputs, and start at the first one. And what this effectively will do is give me all the successive pairs going through. We've talked about this a couple times over the course of this year. But basically, because these are not the same length, I'll go up to the length of the shortest one, which is fine. And it will just give me the 0 with the first with the second, etc. And then I subtract them to get the diffs. And yeah, I think that's all I'm going to need there. I can only just, I mean, it doesn't really matter, but for the sake of, put this right here. Okay. So now that I've got the diffs, I want to start to think about the fingerprints. And so we will say for, we'll say n comma star sequence in zip, and we're going to do number, what do we call it? Outputs. I need the, right, because I'm going to think here, I want to get the outputs. Oh, and I better think about what I'm trying to get here. For each, I'm trying to generate all the fingerprints, right? So let's forget n for 1 second. I'm going to do diffs. I'm going to do diffs, get diffs starting at 1, diffs starting at 2, and diffs starting at 3. And that is going to give me all four sequences of 4. So it'll give me diff 0, 1, 2, 3, diff 1, 2, 3, 4, and etc. So I'll get all those fingerprints. That's going to be my fingerprint. And then I also need to track the number at that point. And so when I do the diffs there, diff number 3 is the subtraction of 4 minus 3. So I want to get outputs 4 there. So I'm going to get the 4th output that is going to match with all those diffs. So now I'll get a fingerprint in seek and the matching output number for n for price. And by the star here is going to read in basically the first, when I zip all this together, I'll get the 4th output, the first diff, the second diff, the third, well, I guess the third output, the 0, 1, 2, and 3, 0, 1, 2, and 3, and this one I'll get the 4th. And I'm going to read, all those things are going to stick in a sequence here. Sequence is going to be these other 4. That star is going to suck them all in. Hopefully that makes some sense. I'm struggling a little bit to describe it. I'm going to say seek is equal to tuple of seek. And the reason I'm doing that is because I'm going to need to keep track of what I've seen already. And because once a monkey sees a pattern, it doesn't re-update, it'll ignore it. So in fact, we're going to come up here and we're going to say seen is equal to set. And a set cannot take a list, but it can take a tuple. So we're going to use that as the key. And then we can say if seek in seen, continue. So if we've already seen this one, don't worry about it. But if not, then we can say, well, then we'll add it, I guess. Seen.add seek, because now we've seen it. I don't know why that came through in that. Like that. And we need a map to track. So this is going to be outside the list. The seen is per starting point. Our list here is going to be seek map or seek totals equal to, and I'm going to want a default dict from collections import default dict. And what this is going to allow me to do is say, let's see, default dict of int. So now any item that I set in there will be a dictionary that I can set the key to. If I haven't set it, it'll be assumed to be an int, which happens to be 0. So now I can say seek totals of sequence plus equals n. So when I get to this sequence, if I were to use this fingerprint, I'm going to add this much to my total, my global total. And what that's going to give me at the end is a seek total dictionary will have all the possible sequences and the total across all of the inputs of how much I would gain if I use that sequence as the fingerprint. And that means I can then look for the maximum. So we will say, we'll delete you here. We'll come down here into part 2 and say we need to get the max of, what are we trying? It's going to be of seek map. Now, when you seek totals, when I do that, it's going to take all the keys. When you do a max on a dictionary, it's going to do all the keys. Now, I don't want the max of the keys. That's just the fingerprints. I need to get the max of the values. And to do that, I will say key is equal to seek totals.get. So effectively, it's going to take a value, pass it into the seek totals.get function, which is going to return the value, and that'll sort based on the value, and I'll get the max. Now I'm going to get the max key. I actually want to get the value, so I'll say seek totals of, like that. And now I can say part2 equals, and save here. And if we didn't make any typos, let's do this on example 2. They did give us an example. 23. Let's see, 23, perfect. Okay, so we'll come up here and do our input. It does take a second to run this, but it wasn't too bad, I remember. It was like 10 seconds maybe. Yeah, so that's not too bad. And we get 1490, which happens to be the correct puzzle output. The tricky things here are basically I make a few passes through. The first time I pass through each number and I generate, so for each number, I'm going to pass through and I'm going to say, give me all 2,000 numbers that I'll generate off of it. And really just give me the last digit, because that's all I care about. Then I'm going to loop over that again, taking each successive pair and creating the differences, because the differences are what I'm fingerprinting. Then I'm going to loop over a sliding window, basically, of every 4 diffs. And I'm going to, if I've already seen that, if I've already discussed it with that starting point, then I can keep going. I'm done with it. But if I haven't, then I'm going to add to my global totals list that if I use this fingerprint from this one, I'm going to gain these many bananas, I think it is. And that's going to give me the answer. So that's it. Getting pretty close to Christmas. And after yesterday, this was a nice easier day down. I will be back at some point soon. Can't promise it'll be tomorrow, but hopefully soon. Thanks for hanging out with me today, and I will see you next time. Bye.